Uranium powers nearly every commercial reactor on Earth today. It is the global standard for high-density energy production, but it is geographically scarce. For India, this scarcity is a significant hurdle. The nation is home to over 1.4 billion people, and its energy demand is rising at one of the fastest rates in the world. Yet, India controls less than 2% of global uranium reserves. However, the subcontinent offers a different resource. While domestic uranium deposits are minimal, India holds roughly a quarter of the planet's untapped thorium reserves. This thorium cannot directly replace uranium. To produce electricity, it must first be converted into uranium-233 inside a specialized reactor. To bridge this gap, engineers developed a three-stage strategy. It uses each phase to produce the specific fuel types needed to eventually power a thorium-based grid. The strategy shifts the country's role from a consumer to a producer. If using imported uranium is like buying food from a global store, the Thorium plan is designed to grow that food domestically. This plan is a multi-generational engineering effort. It is the primary mechanism for India to achieve long-term energy independence. In April 2026, a key component of this plan became operational. At the Kalpakkam facility, India's Prototype Fast Breeder Reactor, or PFBR, reached a major milestone. The reactor achieved criticality. This is the point at which a nuclear core maintains a stable, self-sustaining chain reaction, allowing for the consistent output of power. The PFBR represents the start of Stage 2. It is the first industrial-scale plant in the country designed to move beyond the limits of traditional uranium consumption. The reactor is engineered to produce more fuel than it uses. It generates electricity while simultaneously creating its own future fuel supply. By achieving criticality, the facility at Kalpakkam demonstrates that this fuel breeding process is now functional at a national, commercial scale. The PFBR utilizes spent fuel generated by Stage 1 reactors. This byproduct, otherwise treated as waste, serves as the primary input for the breeder cycle. Inside the reactor, a chemical transformation occurs. The PFBR extracts energy while converting spent material into plutonium. This is the recycling phase of the master plan. The system is designed so that the output of the first stage becomes the fuel for the second. The PFBR acts as a fuel factory. Its primary objective is to build the stockpile of plutonium required to initiate the final phase of the energy strategy. This plutonium stockpile is the necessary bridge to the thorium cycle. It provides the high-energy environment required to activate India's vast thorium reserves. In Stage 3, bred plutonium bombards thorium, causing its atoms to capture neutrons and change structure. This mutates it into uranium-233. Unlike raw ore, this new isotope is highly efficient fuel, capable of powering the grid indefinitely. Stabilizing this reaction marks the completion of Stage 3. It is the endpoint of the roadmap India has followed for decades. The milestone at Kalpakkam confirms that the bridge between current uranium use and future thorium power is now operational. The reactor is now creating the material needed for that final transition. Most nations rely on international markets and finite uranium mines to keep their lights on. By completing this cycle, India removes the constraints of its geography. It creates a self-sustaining system that uses domestic resources to meet its energy needs for the next century.